Yes. 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 Good accuracy.
Okay, very good afternoon to all of you. We are going to start the class 10 syllabus with trigonometric identities. So, suppose there is a triangle ABC. So, in this triangle, the base angle is theta. So, you know that sine theta is perpendicular by hypotenuse, so AB by AC. Cos theta is base by hypotenuse, BC by AC. Sec is reciprocal of cos, so AC by BC. Tan is perpendicular by base, so AB by BC. Cosec is hypotenuse by perpendicular AC by AB, and cot is base by perpendicular BC by AB. So these are the 6 trigonometric ratios. Now we will look at the 3 fundamental identities. So sin square theta plus cos square theta. Suppose if I do sin square theta plus cos square theta, so it is AB square plus BC square by AC square. So that is AC square by AC square, which is 1. So this is the first trigonometric identity. Mind you, these identities are universal. That's why they are called identities. You don't have to be concerned about the size of the angle theta. Okay, these are identities, so the size of the angle doesn't matter. So sin square theta plus cos square theta is 1. This is the first identity. Sec square theta minus tan square theta is AC square minus AB square by BC square. So BC square by BC square, which is 1. So sec square theta minus tan square theta is 1. Cosec square theta minus cot square theta is AC square minus BC square by AB square. So AB square by AB square, which is 1. So sin square theta plus cos square theta is 1, sec square theta minus tan square theta is 1, and cosec square theta minus cot square theta is 1. So these are the three famous trigonometric identities. And remember, the word identities means that they are universally true. You don't have to worry about the size of the angle, you don't have to worry about a situation like this triangle, that triangle, it is universally true. Now, in today's session, I'll only be telling you this much. Now I'll give you some homework, and before that I just want to tell you that the homework in this chapter will be somewhat like, the expansions, factorization expansions of class 9. That means you'll have to see the sum, decide the best identity, and then you have to go for it. Like, you'll have to first see the sum, you'll have to make up your mind which identity is the most suitable for that sum, and then you just have to go ahead with it. So based on that, I am giving you some homework now. Okay, the first homework question for today: prove that sec A plus tan A into 1 minus sin A is cos A. The second homework question for today: prove that 1 plus tan square theta into 1 minus sin 1 plus tan square into 1 minus sin into 1 plus sin A is equal to 1. Tan A plus cot A is sec A into cosec A. One minus cos A into 1 plus sec A is tan A sec A. 1 by 1 plus cos A plus 1 by 1 minus cos A equal to 2 cosec square A. So these are the 5 homework questions. So in all the 5 questions there are 5 identities and you will have to prove them. So I'll just give you one example. Prove that 1 by sec A plus tan A plus 1 by sec A minus tan A. Prove that this is equal to 2 sec A. Prove that this plus this is equal to 2 sec A. So how do you do this sum? You start by saying LHS, then you add both of them. So numerator will be 2 sec A. Denominator will be sec square A minus tan square A. Now sec square A minus tan square A is 1. So the answer will be whatever is there in the numerator. So the answer will be 2 sec A. So what exactly did I do in this sum? Like what was my approach in this sum? See, first I saw the sum. I saw that the left hand side is completely sec and tan. So when you see, remember what I told you, this is like expansions and factorization of class 9. That means after you see the sum, you will have to decide which formula is the most suited for that sum. You will have to make up your mind. So when I saw the sum, I could sense that this formula is going to be the best. Sec square theta minus tan square theta. This will be the best formula because I could see that everything is sec and tan. So then I thought that okay, there's a plus, so I have to add both of them. So I added with LCM. So 2 sec A by sec square A minus tan square A. Now sec square A minus tan square A is a formula. The answer is 1. So the denominator is 1. So answer is 2 sec A. So that means in each of these sums, the first thing you'll have to do is, like you used to do in expansion and factorization in class 9, you have to make up your mind which is the best identity for that sum. Like is A plus B whole square the best one? Is A minus B whole square the best one? You have to see the sum and decide which one is the best one. So in each of these sums, you will have to first look at the question and decide which is the best identity. After you have decided which is the best identity, you will have to apply the identity and get your result. Now there is a small thing I want to say, that in some of the questions, it's very obvious what you have to do. Like in number 5, it's obvious that you have to add both of them. And so that's okay. But in some others, it is not very obvious. Like here you have cos and sec. Here you have sec, tan and sine. Now when it is not very obvious what to do, generally there is a belief that it is better you convert everything to sine and cos. Okay, there is a belief. So I'll just show you one example of that also. So this is the question. Cos theta by 1 minus tan theta minus sin square theta by cos theta minus sin theta. You have to prove that this is equal to cos theta. You have to prove that this is cos theta plus sin theta. So what you do is the left hand side, you take it up, you convert tan to sin by cos. So you know that tan can be written as sin by cos. So you convert tan to sin by cos, then you LCM the whole thing. Simplify the whole thing rather. Now you can take LCM. So the answer came cos theta plus sin theta, which is what you have to prove. So this is what I was telling you, that at times, you will have to convert everything to sin cos, take a few steps and then see what happens. So in this sum, it is a mixture of sin, cos and tan. So I converted tan to sin by cos. I simplified this fraction, then these two I took LCM and the answer came. So this is the end of our first math session of this term, and you have got these 5 questions as homework, right? So I'll conclude the session. Thanks a lot. And you have to submit the homework before 9 p.m. tomorrow. Not 9 p.m. today. 9 p.m. tomorrow means 9 p.m. Tuesday. Okay? So I'll end the meeting. Thank you.